Bismillahirrahmanirrahim. Welcome to my channel. So this is episode 2 for rational algebraic expressions. Rational algebraic expressions. So we have solved few examples, simple one, and these are now factor one, right? So we have to see all those expressions which are in the quotient form, right? So one expression on the numerator, one expression in the denominator, and we have to solve them separately, numerator and denominator, continuously until we have a simplified result, until we have no more to do with respect to the simplification. So we can see that this is a quadratic equation on the top, and something can be taken out in the denominator as well. Dealing with the numerator, so we can break this into four parts, and then we know how to factor it. So we learned that the constant to be multiplied with the coefficient of x square. So this is the first step when we want to factor a polynomial. So 6 multiplied by 1 is 6, and we have to break 6 into two factors. So 2 times 3 or 3 times 2, you can write either way. 3 times 2 is 6, right? So you have two factors, but you need -1 upon addition or subtraction. You need -1. So you can say that if I put 3 as -3 and 2 as +2, I can get the middle term, which is -1x, right? So this is my factor method, and I will be writing it x square minus 3x plus 2x minus 6 divided by, now here I have to see separately what is happening here. Here I can see that x cubed or x power 3 minus 3x squared. So I can take something common, right? So what is common? What is x square? I can take common, right? So what is inside the bracket left? X cubed. If it gives away x power 2 outside or x square outside, I am left with only 1x. Minus 3. So 3x square is gone out, so I am left with only -3. Now I have to see again my factor, which I was doing. So I break it into 4 terms, and now I have to pair it up. The step number 2 is pair it up, and then take out from one pair what is common in the first pair. I can see that x is common between x square and -3x. If x is common, I can put it outside the bracket. In my parentheses, what I left is x minus 3. Similarly here, what I am seeing is 2 is common, and in my parentheses I have left with x minus 3 again. And the denominator is still the same because I have already factored it. So I am working on my numerator. Now my two of the brackets after taking common are same. They should be same always. We learned that in the factor form analysis. So x plus 2, and when the bracket are same, we can write them only once. So I write it once. So I have my denominator as it is, and I can see in my numerator and denominator, I can cancel out x minus 3. So my expression will be x plus 2. I am left with only this, and this is my reduced form or my simplest form. So this will be my answer. Now, one thing which we discussed in episode 1 was restriction. Restriction on the rational number is always important because we don't want to make this p over q meaningless, right? And what is that restriction? Where q cannot be equals to 0. This is the restriction which we have to find out, right? Where q cannot be equals to 0. So we always take this step one step ahead. Like here we have to see at what values my denominator is becoming 0. So my denominator becoming 0 if my x is 0, because if I put here 0, it will be vanishing everything from the denominator. So another one will be x minus 3 is equals to 0. If x minus 3 becomes 0, what x equals to? So x be 3. So x cannot be 3 and x cannot be 0, because if I put x is equals to 3, this bracket will be 0 and making my whole expression null and void, right? So So I want to avoid that situation, because what is my restriction? My q cannot be 0. And q, what is q? Q is the denominator. So at what values denominator is becoming 0? So at the value of x is equals to 0 and at the value of x is equals to 3, my denominator is becoming. So these are my restrictions. So x cannot be, so restriction should be written as x cannot be equals to 0 and x cannot be equals to 3. This is my restriction for this answer, right? So I solve the rational expression until the point where I cannot go further. And then I put the restriction one step before the answer. So before you get the answer, you cannot put restriction here. You have to put restriction before you cancel anything. So now we go to the other question, which is written here. X square minus 16. The bottom is like the same, the 3 terms, right? And I can break them in the 4 terms. And top is very interesting actually, because we have learned something about difference of 2 squares. And this thing can be written as x square minus 4 whole square divided by, I will keep this for a minute like the same, because we will deal with this after dealing the numerator. We can do simultaneously if you want, right? So, but that gives you more strength that what you are dealing with the numerator and what you are dealing with the denominator. So if I write x whole square minus 4 whole square, right? This is difference of 2 square, and the formula we learned was a whole square minus b whole square is equals to, or can be written as, a plus b and a minus b. So that means this thing x whole squared minus 4 whole squared is similar to this, and I can break it as x plus 4 and x minus 4. These are my factor for x square minus 16, right? So x plus 4, x minus 4 are my 2 factors for x square minus 16. Now I have to see the situation with x square plus 9x plus 20. And here again the same thing, breaking it by factor method. What factor method we learned? Constant will go and multiply with the coefficient of x square. That becomes 20. And 20 can be breaked as 5 times 4 is 20. And if I add 5 plus 4, that gives me 9. So I'm good with these 2 factors, 5 and 9. So I can break it as x square plus 9x. Oh, plus 9x. Instead of 9x, I will write plus 5x plus 4x plus 20. I did not change anything. I just factor 9x as 5x plus 4x. And then I pair it up, and then I have to make the common. So what is common between x square and 5x, which is x? And what is left here? X. What is left in the next digit? 5, because x is common. Plus 4 is common. Good. And what is left here in the parenthesis? X plus 4 times 5 is 20. And always these 2 brackets should be same, and we are having same. So we have to write them once, x plus 5 and x plus 4. Now we did numerator and denominator separately. And now we have to plug in these values where we have break them. So for the top one, I can write x square minus 16. I will break it up. What we have here? X plus and x square plus 9x plus 20. So this top or numerator can be written as x plus 4, x minus 4. So I am writing x plus 4 and x minus 4. This is my numerator, which I break it up here. And what is my denominator? It comes out as x plus 4 and x minus 4. X plus 4 and x plus 5. So this is my denominator. And I can see that x plus 4 and x plus 4 get cancelled. So I am left with only x plus x minus 4 divided by x plus 4. What was that? X plus 5, right? X plus 5. So I am left with these two, x minus 4 and x plus 5. This is my answer. It's a reduced form. I cannot do anything further to it. But I have to generate my restrictions because restrictions is one step before my final answer, right here. So my restriction will be coming here when denominator is 0. So denominator will be 0 at x is equals to minus 4, right? And denominator will be 0 at x is equals to minus 5. So minus 4 and minus 5 is my restriction. So x cannot be, when we cut the equation sign, it says x cannot be equals to minus 4 and minus 5, because at these two values my denominator is becoming 0. Hope you understand the questions. If you like this, subscribe my channel and press the bell icon button to receive another video. Thank you for watching.